This PowerPoint is intended to help you get through the very initial stages of using EPANET. First thing you need to do in this is get a decent map that you can put into the EPANET program. I use Google Earth because you can get a picture of just about anywhere. You can also get rough elevations, but you have to convert the Google Earth image over to a bitmap, and I will show you how you do that. First, in your view settings, you want to make this map as big as you can on the image so that you can get better resolution when you start zooming in. You can do that by going to the view setting and make sure that you unclick toolbar, sidebar, everything else. Leave the scale and legend on there right here. Make sure that's checked, but everything else, uncheck it. That way it'll fill up your whole screen and you'll end up with a better image for importing into EPANET. Save that image somewhere where you can find it very easily. I'm going to convert it over to a bitmap. While you're there in Google Earth, you may want to set the path that you're going to be running along for your pipeline, and click on there, Show Elevation Profile in your ad. After you've added it, just right click on the path and it'll give you the elevation, the profile elevation, and you can use this to put elevations into your EPANET model. These elevations may not be exact, but they're good enough for a starting point. Now, to get that Google Earth file as a bitmap, I open that picture that I saved, or that image that I saved, in Paint, and in Paint, when you can save as a bitmap. So it's the same picture, only difference is its save type is bitmap. Click Save on that, store it in a convenient place where you can find it, because the only thing EPANET will take is a bitmap. So now you want to get your bitmap into EPANET. You load it up. In the first screen you'll see, this picture won't be here, but you'll see your toolbar up here. And if you click on View, Backdrop, you'll come over to a load symbol, and on load it will let you go to your browser location where you saved that bitmap and load it in. If it's not a bitmap, it won't show up, so it has to be a bitmap before the load function will even grab it. So grab that, it'll load up in here. You may have to move around or hit View full extent, something like that, if the picture doesn't show up. It's there, it's just not yet shown on the screen as you need it. The trick for using a Google Earth map here is that you have to scale the Google Earth map to match the coordinates in EPANET. And you do that, the way I do it, if you zoom in, there's a little zoom function there to this area right here. You can put in a simulated pipe section, which allows you to get a distance based on the Google Earth map and then convert that over with the scaling factor to for EPANET. To get that scaling factor, you can put a node here. First off, this is your toolbar up here where you can put in nodes, reservoirs, tanks, links or pipes, pumps, valves. I'm not even sure what that is. And the way you do that is you just simply click on that, and then when you click here, it'll put a node there. When you click here, it'll put a node there. Now you've got two nodes, you want to put a pipe in between it. You come up here and grab the little pipe icon, just click on it, then click on here, and then click on here, and then you have to go up here and hit the select key. That allows you to select it. And if you look at your browser over here, it says your link is going to show you your length. So if you right click on this link right here, it'll tell you that the pipe length is about 2008 feet. You get your scaling factor by taking your Google Earth number, 839 feet, and divide it by your EPANET number of 2008 feet, and it gives you a scaling factor of 0.418. Next slide shows you how you use that. So you take your number 0.48, and right in this portion, I'm sorry, over here with view, there's a drop down from map dimensions, and these are your coordinates. These coordinates originally show 10,000. You're going to multiply 10,000 by 0.417, gives you that number. Same thing for the y coordinate. Click OK, and now your pipe length here it'll look different on your map. You can add another one in there and check. It should be around 839 feet. If that checks out, then you're good to go. There's a lot of functionality in your toolbar up here. That's your select key. This is how you move your map around. Your magnifier, your reducer, full scale. Hit that if you don't see your map, and it'll pop back up. Node, reservoir, tank, link, pump, valve, and I forget what that is. Also, you have a browser over here. The browser will disappear if you hit something wrong, but it shows up in the window tab, so go to tab. You will have your node view, your link view, a data view, and a map view. For right now, just make sure the link view has length on there, so that you can actually right click on that link, and it'll show you what the length is. So now you're ready to start building your system, but before you do that, if you know that all of your pipes are going to be of a particular size, or most of them, or any other functions in your system are going to be consistent, you can go to your project tab, and it will have a default setting, and on the defaults you can put in things like what your pipe diameter is going to be. This whole system is going to be 4 inches, so you put a 4 in there, and you don't have to enter this data. Pipe roughness comes default as 120. If you're using new pipe or polyethylene, you know it's 140. You can put a 140 friction factor in there. Don't worry about the pipe length, tank heights, and tank diameters. You're going to have to input anyway, unless you're doing 50 of the same kind of tanks, which isn't going to happen. Also on this tab, you have an ID label over here. If you click on that one, it lets you set the color and size of your nodes and pipes. Properties over here are the facilities themselves, and then the hydraulics. In the hydraulics tab, which I show up the drop down over here, your flow units can be in gallons per minute. Hayes and William, head loss formula, all these things you'll probably leave as they are. There's not much you have to adjust over here. So you click OK on both of those, and you're ready to go. Now you're going to start adding the nodes. You add the nodes by coming up here and clicking right here. And you click on that, and you come down and you click for a node, a node, a node, a node at appropriate locations in your system. You can add a demand or a flow out of any node. So if you want to do it by street, across street, or for each house, if you have few enough houses, you can do it any way you want. But it should resemble what your pipeline is basically going to look like. When you enter your information on your pipes, because they're between nodes, and you've auto-scaled it over here, your auto length is on, it'll automatically tell you what the length is, so you don't have to measure anything there. It gives you a pipe ID, a start and end node, pipe diameter, and roughness. Most of that information will be pre-put in there based on what your defaults are. If you have to change them, you just click on that, and if you want to change that to a 6, you can do that. You can also change all of them as a group, but that's a little bit further down in the lesson. On the junctions, you're going to need to put in an elevation if you want it to look right whatsoever. And if there's a demand, you put the demand in there. But in this example, it's a supply line, so there's no demand. Your elevations you can get off of Google Earth by using the elevation profile. For the tanks, you need to put in an elevation at the bottom. XY coordinates are automatically assigned. It'll tell you pipe ID is 1. You have an initial level in the tank. Maybe put it at about 1/3 of the level. And as you scroll down through here, it also asks you what the maximum level can be in the tank. And then finally, your reservoir over here, you put that in. This is indicating what would be a well, because I have the total head at 261. The ground level here is 291, I believe. So I show the water level essentially in the caisson being about 30 feet below ground level. That's another lesson plan. But in general, if you don't know what to do, put it 30 feet below ground level, and you can adjust that as you get more information. And then you add the pump. Now, the pump is not as simple. the pump itself is going to identify what your hydraulics are in the system. In this particular example, the tank up here is around 471. The level down in the well that you're going to be pulling out of is going to be around 261. That gives you 210 feet of total dynamic head, and I just lumped in an extra 20 feet for dynamic losses right now just to put a pump in there. And so I have a pump that I put in on this curve ID over in the data. Click data, and then a list will come up, hit on the curve, and it'll already identified as curve 1. And the flow, I want 20 gallons per minute out of this system, and the head is 230 that I kind of showed how to get over here. There's another whole PowerPoint on how you do those system hydraulic heads. So we're going to assume that the well can produce 20 gallons per minute. In this particular example, the well couldn't do 20 gallons per minute, but it could do 5 gallons per minute. So those are factors that you have to find out in the field, but this is more about the modeling. Then you assign curve 1 to pump 1. So when you click on your pump right here, and properties, it'll ask you for a curve number, hit curve 1. Now you're all ready to hit it and make it go. So you come over here to the upper bar, hit the little lightning bolt, that means run it. They run pretty quick, and probably you're going to get this right here. Run status, it says it was unsuccessful. For some reason, when I ran it this time, I got that error message, and it was because I forgot to take this pipe out that I put in to get the length of the scaling factor. And so you get errors that look like this, but basically if you find out where 15 is, oh, that was over there, I looked at it, I just deleted this piece of pipe in the nodes, reran it, and then I got a good run. You get a good run, it says you were successful, click OK, and it'll allow you to click on the pipe over here. It'll tell you that the pipe is running at 21 gallons per minute. If that is what you happen to be asking over here, they call a pipe is a link. The node is the nodes that you put in the point, and you can get pressure off of that. Click the pressure, and you'll notice that the flow is also showing over here. And if you have a complex system, you can get an idea of how much flow is going through different pipes. In this example, it's a closed system, so all the water goes up to the tank. When you look at those browser functions, you have two things that you can click on. One is data, and that's when you're setting your system up, and the other is map, which lets you look at it after the run. On the data, if you click on the data, click on this, you'll get this drop-down menu where you can change junctions, identify junctions, reservoirs, tanks, pipes, pumps, valves you can put in. You can label it however you want it. There is a demand pattern that you can put in, and that'll be a future PowerPoint. Your curves, you're going to have a pump curve for your pumps, at least one. And then options. In options, you find things like how you can run this over a time series of, say, a week or a day, every hour, however you want to do it. Those options are there, and that's an advanced function. If you click on the map tab, you'll get nodes and links. And for this one in particular, if we step down on the node, it'll allow you to select pressure, no view, elevation, base demand. If you happen to put a 5 gallon per minute demand at a location, it'll show you that. You can do water quality monitoring with this. You can predict chlorine die-off, your demand, how much water you have coming out of that particular node, the pressure or head at that point, and the quality, your chlorine level if you want. If you instead click on the link function, this drop down will come down. Bulk coefficients, wall coefficients, these are for reaction rates. Flow, velocity are the two that you most often will use, and if you're doing chlorine monitoring, you'll probably hit on quality as well. So these allow you to see these when you click on the pipe or on the node. It'll tell you what the pressure is and the flow, or you could have selected instead what is the base demand or what is the elevation, and for the links what the velocity is, which is very helpful sometimes if you're looking at how things are moving or what the quality is. So with that, the EPANET manual is available. The first time I read it, it wasn't easy to read because I just didn't understand the terminology. But the very first or second chapter, they have a simple example that you can set up, kind of like the one we set up here, and go through. The most important part of all this is understanding what the upper menus are and what they do. and then what the browser does. And to be successful with it, you really do need to understand the hydraulics. And there are a couple of PowerPoints on how you go through the hydraulics for a well system and a distribution system. So make sure you have somebody who can explain to you what's going on with the distribution system. If you're just modeling it, you need somebody who understands the hydraulics to make sure things don't look crazy. Like if you put a pipe in the wrong way, it'll show a negative flow. It doesn't change anything, but you just need to know that. And if you put an improper sign on a demand, it can be pumping water into the system instead of taking water out of the system. So just some things to be careful with. And if you understand the system and it's simple enough, it should be able to work out. So that's it. I hope it works for you.